So, those are the two homework assignments. Did anybody pick up the drafting equipment in the bookstore yet? Okay, a few of you have. Was it $31.50?
3108 or something like that.
Was that with tax or without tax?
Without tax.
Without tax.
It was on the tag.
Okay, so then, $30, was it 9%? That's another $2.70. It's about 35 or so. 33? Okay, okay, so, what I want to do is go over Canvas. So, everybody's get it? You have the class day, the day of the week, the date, the topic. Instructor, what's due, what topics, all the class notes and activities, the reading, and the homework. So today, you're getting a line type homework assignment, and you're getting a multi-view orthographic homework. And the solutions are here, but I haven't, published them yet. What do you notice about class 3? What's different? Is what's due and then this quiz. So that means we're starting our quizzes on Monday. Okay? And the first quiz is on line types. You have to be able to recognize the line types. And for multi-views, given the 3D sketch, I want you to be able to recognize the correct multi-view. I did put on this website, I put the fall's quizzes and solutions on here, and it's posted, so you have an example. Doesn't mean it's going to be very similar, but it's one example of what I used last semester. Okay? And then what's the topic on class 3 is multi-views. Here are the class notes. Here's the reading homework. And then once we start doing more stuff, I'm giving you some more samples of stuff to do. So look in class 3. Am I going too fast? Okay, in class 3, I have homeworks, but notice I have practice problems too. Some of you, when you did the homework, you got it. Some of you need more practice. You're the only one, I guess I could help, assess whether you need more practice or not. But you should know if you need more practice. If you're not getting it like this, you need more practice, and that's why I'm posting extra problems and extra problem solutions. Okay? And class 4 is the same. I'm putting homework down, and then I have extra isometric examples and extra solutions. Okay? And then the same thing on other classes as well. Barbara, are you still working on that Excel table for me? You can work on it today. Okay. All right, so we're just going to go into today's class. Okay? So what I want everybody to grab a card. You might have to move. Grab a card. I don't know how to do this best. Everybody's got to get up. Get up.
I'm thinking that one.
2 lines.
Oh, I'm
1
thinking
check.
this nice strings, lines.
Everybody has one? If I use the yellow one just because it's bigger and people can see it. Okay, so what you want to first do is, well, how many sides are on a three-dimensional object? 6 sides. How many planes? 3 planes. There's the front plane. There's the, what is it, the H-plane? Is that the horizontal plane? Profile plane. Look at your part and pick the side that looks most complex. The one that has the most information going on. And make that your front. Together? Okay, so here's my part. Maybe if you, I don't know if you can see it better like this. Here's my part, right? So I notice when I look at this side, it doesn't have as much information as the reverse, right? If you look at the front, that you chose the front, and look at the back, they're similar, right? They're just opposites. They're like mirror images of each other. If you take the left side and the right side, they're kind of mirror images of each other. But one side usually has more information going on. Like this side has more information. Could you see it better when I hold it up like this or when I do this? Hold it up. So this side has more information than that side, right? Wouldn't you agree? And this side has more information than that. So when I pick my front, I would either pick this or this. I'm probably going to pick this. Okay? So this is going to be my front side. Okay? Now, there's something referred to, these are called what? Pictorials, right? They're three-dimensional drawings. There's an oblique and an isometric. And what they're doing is they're communicating the information from three different sides. But let's say we didn't want to draw something in 3D. Instead, what it's called is a multi-view. Multi-view because there's more than one view. Since there are three planes, you need three views to communicate a drawing. Three sides. So if, like I do with the oblique, I'm going to look at my front side with my perpendicular eye, and I'm going to see this edge, this edge, this edge, this edge, this edge, this edge. So on your piece that you chose the front, I want you to look at, feel, what are the edges that you're seeing?
Well, from this side,
And now look at the top of your view. Look at the top of your part. What edges do you see here? Now notice, I'll go to each table. When I'm looking at my top, I see these edges. But if I look on the bottom, there's an edge here that I don't see. I'll do it this way. On the bottom, there are edges here that I don't see from the top, right? But I want to communicate that those lines exist, because when I draw my multi-view, each side has to show the complete plane. So for you guys, when I look at this side, I'm going to look on the back side. There are some edges here that are on that plane that I don't see from the front. But when I draw the front, I'm going to communicate those in some manner. Okay? Because it is still describing that plane. So what I have over here, oh, here's another one. Edwin, you can have yours back. Okay. Let's turn this one. So what I'm doing, I have this box. Flip it over. You have this box. And this I've decided is my front side. And what I'm going to do is I'm going to look from the front and look at the details of that front side. And then I'm going to look from the top and look at the details of that top side And I'm gonna look from the right side to see the details of the right side. And then I'm gonna open them up so that I actually have a multi-view. A front, a top, a right side communicating this part. So instead of drawing, or in addition to drawing a 3D drawing that shows the three sides, I'm also gonna draw multi-views. And they're also referred to as orthographic drawings. So let me show you some examples. Okay, so I'm on class 2. I'm under multi-view. See the word orthographic there? Up to 10 years ago, these were called orthographic drawings. Each one is really an orthographic drawing. Ortho means perpendicular. My eye is perpendicular to the plane. But now they usually use the term multi-view to show all three sides together. So I'm opening up this. So here we have a part. You told me that there are three sides, right? The front, the top. What else is the top called? Horizontal. What about the sides? What are they called? Profile. So the top and the bottom are both horizontal views. The front and the rear are front views. And the left and the right side are profile views. If I look at it from the front, does it make sense that I would see this? So from the front, I see a box, and another box. Here are my three boxes that I see. And then I see this curved piece, and the circle. So now look at your part and look at just the front, and think about what you would draw to only denote the front. Okay, now, looking at the top, this is curved right here, but from the top, I can't tell that it's curved because it's all in the same vertical plane. And I'm gonna see this come out and this come out, and it's gonna be like this. But there's a piece of information that's going on that I have to denote. You see this circle that's here? In the front, I show the circle because that happens to be an edge, a physical edge that I can see. But this circle here represents a hole that goes through the part, and when the hole goes through, it's going through the back part. So does anybody know what these lines are called? They're dashed, and they're called hidden lines. These lines are called visible or object lines, and the lines of edges you can't see, but you want to represent are the hidden lines. So look at the front of your part, and then look at the back of your part. Is there anything in the back that you would want to communicate? Is there an edge in the back that you would want to show in the front? And if there is, what type of line is that called? A hidden line, and it's a dashed line. So not only in this example did they show you the front and top, but they also showed you the bottom. You could see the similarity between top and bottom, right? They also showed the sides, and you could see the similarity between the left and the right side. And you could also see the similarity between the front and the rear. Because there's so much similarity, when you do our multi-views, you only need 3. Just like in the oblique and the isometric, you only show 3 views, you only show 3 views. What are the standards? The front, the right side, and the top. Let's look at the next one. Here, they're showing you, here are our 3 orthographic views, and together they're called multi-views. So here's the object, here's the front view, the top view, and the right side view. Engineers want to be efficient. We want to be as detailed as we need to be, but we don't want to do extra work that's not necessary. Showing the front and the back view is not necessary. Showing the left and right side is not necessary. You only need those 3 views. Yeah,
What if
Andrew.
what if the object doesn't have that much symmetry?
Good. Well, then you still only need the 3 views, but you might add a sectional view. But let me answer your question in a different way. What if you don't need all 3 views? Let's look at some examples. So So typically on an engineering drawing for each part, this is considered one part. Why is it one part? It's all cut from one piece of material. If I had this part and this part together and they were connected, then we would have two parts plus the connection, which would be a third part. Okay? We're looking at one part, it's cut from one piece of material. So in this case, what you do for one part is you show your three orthographic views, or multi-views, and typically you have a 3D drawing. So engineering drawings, typically have a 3D view, a front view, a top view, a horizontal, and a profile view. Okay? This is a typical working drawing for one part. So if you as an engineer design something that has 5 parts, how many of these would you have? 5. So what I want you to do now is open up the packet that I gave you. The next page is one set of multi-views. So Andrew, to answer your question, when a part is really complicated, you still represent the three views, and you typically add something else, like a sectional view or an auxiliary view, which we haven't talked about yet, something in addition to it. So where are you in the packet? The next page. So we're looking at this sheet. Pull this sheet out. And I see that you already figured out the drafting table. You can either put it up if you want, or you could lower it. It doesn't have to be at that big of an angle. It's whatever you're more comfortable with. Put it back up. One thing that's helpful though, if you do put it up at an angle and you put a piece of paper on it, it's going to slide down. So there's something called drafting tape or drafting dots. It's basically masking tape that's cut in a circle. So if you want to have it angled and it's sliding down, you can use the drafting tape, and this comes off. Okay, and I'll put it up here. Okay, so let's take a look at that multi-view drawing. So everyone has a pencil now, because I gave it to you. I'm going to tape mine down. What kind of drawing did they give you? What drawing is given down here? It's a pictorial and it's an isometric. And how do you know it's an isometric? It's off 30 degrees. And on this drawing, an isometric, just like I have, oh, I took it off over here. This is an F, and this is horizontal. So whenever we look at isometrics, this is always the front view. This is always the front. Now to start out, whenever you draw, you want to use construction lines. Construction lines are the only light lines. You don't make it dark until you're sure. I know we have erasers, but it's typically we do things light first and then darker. So let's take a look at this. Does this make sense? This is my front view. What edges would I see I would see this backwards L, and I would see a rectangle. And this looks good to me. And remember, all these lines are visible lines, and they're considered thick lines. Hang on a second, Andrew. So I want to make sure that they're thick. When you see photocopies of things, sometimes it doesn't show that it's thick, but all these lines are thick and dark. Andrew?
There we go.
The other thing that's really important to know, take a look at this. This is my width of my drawing, of my part. This right here is the depth, and this right here is my height. There is no length. It's width, depth, and height. So width is this, height is this. What dimension does the front and the side view have in common? What dimension does the front and the side view have in common? The height. They both have the same height. What dimension does the front view and the top view have in common? The width. What dimension does the side view and the top view have in common? Depth. So I'm going to go up, and I'm going to draw this. So this I could draw at a 45 degree. Could everybody look at what I just did? I took this, I drew a line going up at 45 degrees, and I went up from the side view, and I went over. Up and over, and now I know the depth of this. So I know the top view is going to be within this rectangle right here. Oh, they give you a big head. And they're because they didn't buy a 6-inch one, they bought these. And this is just 2 cups, so I had them pull it from the kit, that's why. And then I bought the little ones for you guys. Okay, let's look at the right side view, the profile. What are these lines called that I'm darkening in right now? Do you remember? Visible or object. And they're thick, dark lines. So what do you notice? Everybody look up here. When I look at it from the right side, I only see the box, right? But what else is going on here that I don't see? There are edges, right? There's a cutout piece. So I have to show that, and what kind of line are these? Hidden lines. So I want you to finish all 6 of those sides. something else I find helpful, and I do have some up here, is Play-Doh. When you're giving a 3D object, you can make it out of Play-Doh, cut it away, and then you could rotate the object and see what it actually looks like when you turn it, so that you're looking at it perpendicular every single time.